I wanted to show you how to use some software in order to take a percent related to a normal calculation problem and convert it into a z-score or an x value. So let's give this a try. Let's try it out with a problem. First, we're going to use GeoGebra, and again, I'll provide you with a link that you can use to get to this normal calculator in GeoGebra. Let's take a look at a problem here. So let's say the first one's a little tricky because the middle 50%. So let's start with maybe the number 3. The length of a football field is normally distributed with a mean of 100 meters and a standard deviation of 3 meters. Now, I gotta be honest, I don't know that this is a realistic calculation. Let's see here. Football fields from end zone to end zone are 100 yards. It's possible that if you include the end zones that it's 100 meters. Maybe we got to do a little double checking on that. Anyways, let's see here. The standard deviation is 3 meters. Under what size are the smallest 10% of football fields? So let's take a look. Let's see here. And then again, with regard to length, not area. So we've got a mean of 100, and let's go ahead and put that in. And we've got a standard deviation of 3. And then 10%, that we want the lowest 10%. Now, for those of you who have been wondering, why did we have to spend all that time looking at z-tables? Well, it turns out that even using calculators like this, sometimes, well, I guess this particular calculator, we could have gone to the right or to the left, but a lot of times calculators like this will expect you to put in the number to the left of the z-score you're interested in, or the x value you're interested in. And in this case, let's see, so let's say we did it this way. So what's the probability that x is less than, the thing that's interesting here is we've got this number 10%. So we're going to actually, this time, instead of putting a number in here, we're going to put the number over here. And for 10%, we'll do it as a decimal. And when we do, it should show us what size football field. Let's see here. Well, how did they say that? Under what size are the smallest football fields? So I guess what this means is the smallest football fields must be below 96 meters, or approximately, but below 96.15535 meters. Now, it is, well, let's leave it at that. This one, we definitely wanted to know the probability. We wanted to know the percent less than a particular value, and so using the less than made a lot of sense. Let's try the greater than example. So here they're saying that when you go to buy this paper, with a mean of the width of the paper has a mean of 210 millimeters, and the standard deviation is 0.2 millimeters. So what size are the top 20%? So let's try 210. That's the mean. And interestingly, wow, they really chop this paper accurately. For it to be 210 as the mean and 0.2 as the standard deviation, they are doing a pretty good job at chopping that paper accurately. Okay, then what we want to know is, what is the top 20%? Well, one way we could do it is we could do the bottom 80%, like we have been doing with the z-table. So I'm going to put that in there. And that gets us, what that is telling us is that the top 20% pieces of paper, according to this problem, would be above 210.16 or 0.17 millimeters. That's what it would be. Now, because they also let us do a greater than, we're going to go ahead and flip this around. And, it knew what I wanted to do. Let's say it didn't know, though. Let's say it came up and it was like, I don't know, 0.5. We would go and we would take the 20%, the 0.2, and we would put it here. Let's try it, 0.2. And the thing that I like about using the software to do this stuff is that just in case you are one of those people that are not motivated to make a picture, make a picture, make a picture like you should be doing for all these problems, the software does the work for you. We could see if for some reason we had screwed up and we had accidentally done the wrong thing over here. Let's say we did 0.2, but we did it like this. We could see this shading is clearly not the top 20%, okay? And so that would give us the clue that maybe we need to change something. In this case, let's use the right-sided, and let's change this to 0.2. And now we can see, okay, we're talking about the top 20%, that's the shading, and therefore we're talking about all the paper that is, let's see here, the top 20% pieces of paper will be 210.17 millimeters or more. That'd be the top 20%. Okay, now one other thing that we've looked at is what about the middle? So what about the middle 50%? Let's try. So we're going to do something like, I'm going to do something like this. And I'm just going to go ahead and type, let's see, I'm just going to go ahead and change this number. Oh, maybe it won't let me do a percent on this. Hold on, hold the horses. Hold on 1 second here. Well, sadly, I discovered that the GeoGebra calculator does not let you do the middle percent. So we're going to have to do this. We're going to have to help the GeoGebra calculator a little bit. What I did is I copied the curve. I made a picture. In this case, we got lucky. I don't know if you remember from the last video, I was saying that these guys are not necessarily standard deviations down here on the x-axis. In this case, because the standard deviation is 0.2, they actually are the standard deviations. So I went and I drew the lines to indicate these are my standard deviations. What else? We've got the problem that we've got to look at. We want the middle 50%. You know what? I got to make sure the numbers are right here. Hold on. Okay, so the problem we're working on is skydiving with a mean falling time, a mean free fall of 20 seconds and standard deviation of 2 seconds. That seems a little strange to me, but again, we'll just go with it. Anyways, what times do the middle 50% of jumpers free fall for? Well, let's take a look. According to GeoGebra, if I put mean of 20 and standard deviation of 2, I get this picture. Again, I got lucky that the 22 and the 24 and the 18 and 16 actually are standard deviations, so I put lines to indicate that. But what we want to know is the middle 50% according to this problem. So where do I put my cut points? Where do I put my cut lines? I'll make them in red. Middle 50%. We know that if we go out to this far, we know percent-wise, if we go out to here, that's 68%. So the middle 50% must be lines that are somewhere in between there. They couldn't be outside there because that'd be more than 68%. So let me get rid of all that. And let's go ahead and just middle 50%. I don't know. I'm not sure. I'm just going to kind of go like this. There's my 2 cut points, and each of them should have a z-score, and I basically want to find these z values. Z equals what? Z equals what? Or actually, maybe they're x values. I think we're actually looking for the x values according to this problem. Yeah, we want to know the times for the middle 50%. So we're actually looking for the x values. So forget about the z values for now. Unfortunately, the calculator, I think, will help us go right for it. But we got to feed the calculator the correct percents. We cannot simply put in the 50%. We would love it if we could just, go, well, okay, calculator, 50%. And boom, tell me the result. It's not going to do that. So what we got to do is figure out, well, what percent is associated with this x value? Well, it's the percent below. So I'll shade that area. Something like this. all the way down to there. Okay, so what percent is that? What is the percent that I need to tell my handy dandy calculator? And by the way, we'll do a less than, and we'll just put in whatever percent we need to with the mean of 20 and standard deviation of 2. So, well, we know that this is 50% right up here. This is 50 because we were told middle 50%, right? And that means that from like here all the way to here, between those two, that must be 25%. And I'm gonna let's see, we'll make that a percent. There we go. And then the other thing that we know is if we go all the way from the center all the way to the left, we know that's going to be 50%. By coincidence, they happen to be the same number. And so what we've got to do is we've got to take this 50% and subtract this 25%. And when we do, we get 50% minus 25%. And when we do that subtraction, of course, we get 25%. This equals 25%. And just by coincidence, it happened to be 25%. Okay, so this is the number we have to throw in to find this x value. So let's go ahead and do it. So 25%, 0.25, and that gets us to 18.65, yay, approximately. Let's see here, so we'll do red, 18.65, and that is seconds for people jumping out of an airplane. And then to get this other percent, we take this I see a little problem with my situation here. Never mind, I'm good. I figured it out. So actually, I'd like you to pause the video and I'd like you to figure out what percent is to the left of this cut point right here. Well, if we went and shaded it in, maybe let me use a different color here, maybe blue. If we had to shade all this in, all the way over, like such. Okay, if we had to go all and shade all that in, what percent of the curve is to the left of this cut point? Take a moment, pause the video, see if you can figure it out. Okay, yeah, I hope you tried on your own. I'm going to tell you what I think. I think since we go from here to here is 50%, and if we go from here to here is 25%, I think we're talking about 75%. So I'm going to go ahead and put in 0.75. And that gets me 21.35. 21.35. So let's put that in. 21.35. Okay, so now I have now shown you how to use the this GeoGebra calculator in order to find x values when given the lower. Let's see, if we want to find the lowest 10%, the upper 20%, and the middle 50%. I'm going to give you 3 problems just like that you are going to try with the GeoGebra calculator. So here are 3 problems for you. And I'm going to give you multiple choice answers for these guys. I expect you to use the GeoGebra calculator to try to get these answers. If you really want to, you can use z-tables or use both and double check your answer. I'll give you a couple of tips. Be careful when you work with the 5%. Remember, that is not 0.5. It's 0.05. I have to admit, I had to think about it myself. What else? This one is always going to be tricky, the middle 80%. Definitely take a minute and review my example with the middle 50% to make sure that you know what you're doing. And I think that's it. I'm going to just hang out here for a minute so that I have enough time to put some quiz questions in here for you. Oh, let me give you some words of positive affirmation, okay? First of all, you are good. You are smart. You can do this. You just need to focus and make this happen. I know you can do it. I believe in you.